Once again, welcome to my viewers. In this video, we'll discuss the sum of infinite terms of a geometric progression. Let us recall the general definition of a geometric progression. It is written as first term is a, second term is ar, third term is ar square, fourth term is ar cube, and so on. Nth term is a into r to the power n minus 1, and so on. Now let's say this series contains infinite numbers of terms. Earlier we have discussed the sum of n number of terms of this series. We find that Sn equal to a into r to the power n minus 1 divided by r minus 1. This is the sum of n number of terms of this series. Now let us think about if this series contain infinite numbers of terms, and let's say if r is less than 1 and it is greater than minus 1, right? R lies in between 1 and minus 1. That means r is a fraction, it is greater than minus 1 and less than 1. Then think about the sum of this series. If this series contain infinite numbers of terms, we will write it as S infinity. That means sum of infinite number of terms of this series. S infinity means a plus ar plus ar square plus ar cube plus a into r to the power n minus 1 plus up to infinity, suppose. Right? Now think about what would be the sum of this series if r lies in between 1 and minus 1. Say for example r equal to suppose 1 half 1 by 2. Then what would be 1 by 2 to the power infinity? It is approximately equal to 0, right? 1 by 2 to the power infinity, or 1 by 3 to the power infinity, 1 by 4 to the power infinity, 1 by 4 to the power infinity, approximately equal to 0. Why? 1 by 4 to the power infinity, suppose, equal to 1 by 4 multiplied by 1 by 4 multiplied by 1 by 4 multiplied by 1 by 4, infinite numbers, infinite times. Then you know the numerator will be 1 only, 1 multiplied by infinite times 1. So denominator will be 4 to the power infinity. Now 4 to the power infinity, you multiply 4 infinite numbers of times, so it would be equal to infinity, very large number, so we call it infinity. So now 1 by infinity, it is approximately equal to 0, right? When you divide 1 by infinity, it is approximately equal to 0. Therefore S infinity equal to a into r to the power infinity minus 1 divided by r minus 1. So it is a into r to the power infinity means it becomes 0, 0 minus 1 divided by r minus 1. So it is a into minus 1 divided by r minus 1, that is minus a divided by r minus 1, or you can write it as a divided by 1 minus r. So sum of infinite terms of the GP series is a divided by 1 minus r, right? Now let's do one example of this type. Say question 1, find the sum of 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 up to infinity, right? So how do you find this? Here a equal to 1 and common ratio R is A2 divided by A1. That means 1 by 3 divided by 1, that is 1 by 3. So you find that R lies in between -1 and 1. R is less than 1, right? And you have to find the sum of the infinite numbers of terms of this series. So S infinity equal to, you remember the formula, A divided by 1 minus R. Here A means 1, 1 minus R, R means 1 by 3. So it is 1 divided by 2 by 3, that is 3 by 2, or it is 1.5. So sum of infinite number of terms of this series equal to 1.5. Let's do one more example here. Say for example, question number 2, 1 minus half plus 1 by 4 minus 1 by 8 plus up to infinite number of terms. Let's find the sum of this series up to infinite number of terms. Here you find A equal to 1, common ratio R means second term divided by first term, minus half divided by 1 equal to minus half. So you find that R is greater than minus 1, less than 1. Minus half is greater than minus 1, right? So S infinity equal to A divided by 1 minus R. Here A means 1, 1 minus R, R means minus half. So it is 1 divided by 1 plus half. So it is 1 divided by 1 half means 3 by 2. So it is answer is 2 by 3. This is the answer, right? So thank you viewers for watching this video. We will do similar exercise in the next video again. Keep in touch.